A particle moves according to a law of motion, s is equal to f of t, where t is greater than or equal to 0, where t is measured in seconds and s is in feet. The function that we have, f of t, which is equal to t cubed minus 12t squared plus 36t. What we want to do is we want to be able to find the velocity at time t. So this function represents the position function, and we want to find out what is the velocity. Well, the velocity function is equal to the derivative of the position function. So if we find the derivative, well, the derivative of t cubed is 3t squared minus 12t squared, which becomes minus 24t, and then plus 36. So therefore that represents the velocity at time t. Now in part B it says, what is the velocity after 3 seconds? So what we're going to do is we're going to find out what is the velocity of when t is equal to 3. And then we're going to plug it in. So we have 3 times 3 squared minus 24 times 3 plus 36. When we evaluate that, we end up getting -9, and that's -9 feet per second. Okay, now the next question is asking us, when is the particle at rest? So when is the particle at rest? Well, the particle is at rest is when the velocity function, or v of t, is equal to 0. So our function v of t that we found in part A is 3t squared minus 24t plus 36, and we set that equal to 0. Now if we factor out a 3, then we get t squared minus 8t plus 12, and that's equal to 0. And if we factor this, we end up getting 3 times t minus 2 times t minus 6, which is equal to 0. So if we divide both sides by 3, then we end up getting t minus 2 times t minus 6, which is equal to 0. And so we have t minus 2 is equal to 0, or t minus 6, which is equal to 0. So therefore t is equal to 2, or t is equal to 6. So the particle is at rest when it's at rest at the following: 2 seconds or 6 seconds. Okay, the next question in part D is asking us, when is the particle moving in a positive direction? Okay, now the particle is going to be moving in the positive direction when the function v of t is going to be greater than 0. So that means that the function that we found, or that we factored, was 3 times t minus 2 times t minus 6, and that's greater than 0. So what that means here is that we have the following. So if we take a look at this graph, right, we know that we're going to have two values of t where they are equal to 2 and then 6. So from our previous exercise, or previous step, we know that we have 2 and then we have 6. Okay, and so we have these regions, and what's happening with these regions? Well, where is the particle moving in a positive direction? So if we check region number 1, and let's say we let t is equal to 0, and then we plug it into 3 times 0 minus 2 times 0 minus 6, is that going to be greater than 0? Well, that's going to be 3 times negative 2, which is negative 6, times negative 6, which is going to be positive 36, and therefore it's true in region 1. If we check out region number 2, if we let t is equal to 3, so we have 3 times 3 minus 2 times 3 minus 6. We want to see if that's greater than 0. So that's 3 times 1 times negative 3, which is negative 9, and therefore it is false there. And then if we take a look at region number 3, let's pick a value for when t is equal to 7. So if we have 3 times 7 minus 2 times 7 minus 6, is that greater than 0? Well, 3 times 5 is 15, times 1 is 15, and we know that's greater than 0, so therefore it's true there. So we know it's true in those intervals. So where do we know that it's true? Well, it's going to be true from when t is equal to 0 until 2. Now remember, since this is greater than, we have a parenthesis there, and we know it can be equal at 0. So that means that we know that it can be true from 0 to 2, or we can say that it's going to be 0 less than or equal to t, which is less than 2. That's one solution. And then we also know it's going to be greater, it's true when it's greater than 6. So that means when it's greater than 6, or we can say this as t being greater than 6. So there are the values of when it's moving in a positive direction. Because over here we can see that our values are positive, so therefore the particle is moving in a positive direction in those particular intervals. Okay, now let's find the total distance that's traveled during the first 8 seconds. Now, since we know that the particle is moving in a positive direction and in the negative direction, we need to calculate the distance traveled in those intervals. Okay, so we know that it's going to be traveling from 0 to 2. That's one of the intervals. So the intervals that it's going to be traveling is from 0 to 2. And then we know it's going to be traveling between 2 and 6. And then it's also going to be traveling from 6 to 8, since we want to find during the first 8 seconds. Okay, so we want to find them separately. So what we want to do is we want to find what is the distance between 0 and 2. So that means we want to find, okay, what is the absolute value of f of 2 minus f of 0? That is the first interval. So since we want to find the distance traveled, we're not using the velocity function, we're using the position function, which is t cubed minus 12t squared plus 36t. So we're using, again, t cubed minus 12t squared, and again that's plus 36t. So that means that we have f at 2, so that we have 2 cubed minus 12 times 2 squared plus 36 times 2 minus, we have 0 cubed minus 12 times 0 squared plus 36 times 0. And so what that gives us is 32 minus 0, which gives us a distance of 32. So from traveling from 0 to 2, we can see that it gives us a distance of 32. Okay, and now what we want to do is we want to find out, okay, what is the distance from f of 6 minus f of 2. We already know what f of 2 is, so we know that plugging in 6 cubed minus 12 times 6 squared plus 36 times 6, and that's minus 32. Well, if we plug in 6, that means we're going to get 0, and then 0 minus 32 is going to give us a positive 32. And then we want to find the distance from when f of 8 minus f of 2. So we have 8 cubed minus 12 times 8 squared plus 36 times 8. And then we're subtracting 0 because that should be f of 6 here. Let me correct that. That should be f of 6. So that gives us 0. So therefore, if we plug in 8 into that function, then we end up getting 32 minus 0. And the absolute value of 32 is going to give us 32. So again, we want to find the total distance. So the total distance is 32 plus 32 plus 32, which is equal to 96 feet. Okay. Now let's draw a diagram like figure 2 to illustrate the motion of the particle. Okay. So we want to draw a diagram. So if we have a diagram here, let's create a line here. Okay, and with this line, we know that we have a value of s, and let's say this is 0. Okay, so we know that when t is equal to 0, we know the position is going to be at 0. Okay, and then it's going to keep going until we get to 2. So what happens when it's at 2? Well, when it gets to 2, we know the position is going to change. So if this is 1, and let's say that this represents 2, okay, so when t is equal to 2, or 2 seconds, we know that the position is going to be 32. So what that means here is here we start, and then we're heading towards the value when t is equal to 2, and then it's going to change direction, because now it's going to go back to when t is equal to 6. Well, when t is equal to 6, we know the position goes back to 0. And then we also found out that it's going to keep going in its direction because we know that at t, or when t is equal to 8, we determined from above that the position came back to 32. And so therefore there is the drawing of that particular diagram. Okay, next. We want to be able to find the acceleration at time t and after 3 seconds. Well, remember that the velocity function from above was equal to 3t squared minus 24t plus 36. And then recall that the acceleration function is the derivative of the velocity function. So if we take the derivative of that, it's going to give us 6t minus 24. And then we want to find out what is the acceleration after 3 seconds. We want to find a of 3. So we're going to plug in 3, so 6 times 3 minus 24 is going to give us -6, and that is feet, -6, and that's feet per second over seconds, which is actually equal to -6 feet per second squared. Okay, now we want to be able to graph the velocity function, the position function, and the acceleration functions for when it's between 0 and 8. So let's go ahead and do that on Desmos. Okay, so we're gonna graph first the position function, which is t, or we're gonna call it x cubed minus 12x squared plus 36x. So therefore there is our position, and then the velocity function is 3x squared minus 24x plus 36. And then we have our acceleration, which is 6x minus 24. Okay, now we want this to be in between 0 and 8. So in the x-axis, let's say we're going to go -1 and then +9. And then let's maybe make this -12 to +40. Okay, so then let's take a look at this graph here. Okay, so we want to focus what's happening between 0 and 8. So we want to make sure that we graph that part in between 0 and 8. Okay, so we know that the red represents the position function. We know that the blue represents the velocity function, and the green represents the acceleration function. And so now what we want to do is we want to be able to find out, okay, when is the particle speeding up and when is it slowing down? Okay, now the particle is speeding up when the velocity and the acceleration have the same sign. Okay, so if you take a look at the interval between 2 and 4, so let me go ahead and highlight that. So the interval between 2 and 4, we can see that here the velocity is negative, and we can see the acceleration is negative in between that interval. Okay, and then since they're both negative there, and then here at 6 and on, we can see that the velocity function is positive, and also from 6 and on, the acceleration is positive. So therefore, this occurs when t is in between t and 4, when the velocity and acceleration are both negative, and when t is greater than 6, when the velocity are both positive. Okay, now we want to find out when is it slowing down. Well, it slows down when the velocity and acceleration have opposite signs. So if you take a look at this interval here, okay, we can see that the velocity function is positive, where the acceleration is negative. So therefore, it is slowing down between 0 and 2. And then also between 4 and 6, if you look at between 4 and 6, okay, we can see that the acceleration is positive, but we can see that the velocity function is negative, which is below the x-axis. And therefore, again, it's slowing down between when they have opposite signs. So we can see that in between 0 and 2 and 4 and 6.